We're moving on to section 12, where we will be completing the square and shifting parabolas. So in a few of these problems, what we're going to do is, I guess we could just use this graphing calculator, and we can just talk about how it is shifted after using the graphing calculator. So if you notice with this first one, they have y equals x squared already on the graph. So I'm just going to type that into my calculator, and then we have x minus 4 plus 2. So y equals x squared. And then on the same graph, I'm going to just put in x minus 4 squared plus 2. And so what you should notice as my graph shows up, that my new graph, the vertex is not at the origin, but it's shifted right 4 up 2. So right 4 up 2. I kind of wanted that red color to show up. There we go. And it goes up by the same pattern of up 1 and then up 3, up 3, up 3 on the other side. So the graph pretty much takes on the same shape, except the location of the vertex changed. That it went right 4 and then up 2. And maybe just think about it for right now. Let's see if there's a pattern between those values and the other one. So I'm going to do part B with just a different color. And I think mine's set up as a light blue. But now we're going plus 3 minus 5. X plus 3. And then minus 5. So, well, look at that. It shifted left 3 and then down 5. So let me use this color. Left 3 and down 5. And see if we can come up with some rules here. 1, 2, 3. 1, 2, 3, 4, 5. And it still has the same pattern, where it's going up by 1 and then up by 3 and so on and so forth. So it looks something like that. And the thing is that we're looking at this pattern. Well, let me write it out. So what's happening, I don't know where I want to write it though, is in these forms, maybe I'll sneak it right here, is sometimes what we'll do is we'll write this in this way, x minus h squared plus k. And notice that this minus is important, because if you see the phrase minus that number, and I'm using h because it's that way, you'll see it that way in the future, that's going to be right that many units, whereas if you see plus h, it's going to be left that many units. And on the outside, if you see a plus k, that's normal, that's how we get up. And then a minus k, that's how we're going to go down. And all of those rules apply as we look at our graphing calculator. So if we look at the next one, if we wanted the turning point, now remember I like to call this the vertex, to be located left 6 and down 2, and think about all the rules that I established. Now, yes, you could use a graphing calculator to verify that this is correct, but what it needs to come out to be is, in order to move left, we need to add inside. So that's how we get to the left, is adding inside, and then down, it has to be minus on the outside. So on the outside is up and down, and on the inside is left and right. So as you look at all of your options, I believe it's option 2. So as we look at the next one, again, it uses the phrase turning point, but you know me, I like the word vertex, that's the math term. Well, if we're trying to look at this without a calculator, it's going to be shifted right 8, and then that's going to be down 4. And these are good rules to memorize. It makes problems go a lot faster. Well, if our vertex is right 8, it's going to be a positive 8, and then down 4 would be a negative 4, so that corresponds to option 4. And since we have the time, at least my video doesn't look like it's ridiculously long yet, I could play around with some of these options and type it in. Maybe I'll do this first one. If I were to type in x plus 6 right there, and then minus 2, and then maybe on the next one I can come up with the minus 8 minus 4. And if I go to my graph, I can actually see the red one was left 6 down 2, just like what we wanted, -6, -2. So that was correct. And then as I looked at the last one, it was shifted, let's see, it was this baby blue one. Maybe I mistyped it because it's supposed to be shifted right 8. Yeah, I sure did. I don't know what I was doing. X minus 8. And if I go back to that graph, now it does look right 8 down 4. So I think I did it correctly. I just typed it into my calculator wrong. And I already warned you that this is how you're going to see it. So if you were already looking ahead, that's your vertex form or the turning point of the parabola. And so let's get into a little bit of the trickier kind of things that you'll have to do. So in this first example is you want to rewrite it from this form where it's y equals x squared plus bx plus c into this form. Now there's a couple ways that you could do this, but we're going to practice what is called completing the square. And what you do, or what I've done in the past, is I just take that problem, x squared plus 8x, and I put a blank right here, plus 7, and then another blank. And I go through the same process over and over again, where I look at this number, I want a more vibrant color, this 8, and you always divide it by 2, and then you square it. And it's always the same process to get, in this case, it comes out to be 16. Now you can't just randomly throw in a 16 in the problem. You can do that if you later subtract 16. And so what I'm talking about then is if I group the first 3 terms together, that's a perfect square trinomial. And instead of writing it as x plus 4, because that's how you would factor this, factors of 16, that had to be 8, we can write it once squared, and then on this side, 7 minus 16 reduces to -9. So that's how we could use this process to get this answer. So now we can find the turning point because we can shift it left 4 and then down 9, and that's where our vertex is located. Now they ask you to use your graphing calculator just to make sure you have the right answer. And there's a couple ways you could check with your graphing calculator. One way would be to start with the original problem, x squared plus 8x plus 7. And I'm also going to type in the answer I got, x plus 4. And if I did this correctly, these 2 curves, if I go to my graph, will fall directly on top of each other. I saw that first one, but that red one got hidden really quickly for my new answer. I can also look at the tables. If I go back to my tables, I'm looking specifically at my red and my baby blue problem there. But what I actually only care about is that the turning point happened at -4, -9. So it might make sense if I cleared out this other one, go back to my table and show that the turning point happened at -4, -9. Yeah, so we're good. So let's practice that technique a couple more times. And again, this is just how I do it. You don't have to do it my way. There are other ways around it. My way just makes sense to me. So again, your process, you look at that middle number and you divide it by 2, and then you square that number. So -6 when you divide by 2 is -3, and once I square it, I get +9, but I can't just randomly put a +9 in there. I have to later subtract 9. And why do I go through that process is now I can group the first 3 together, and that would simplify to x minus 3, x minus 3, if I factor 9 to get negative 6, but I can just write it once squared, and then combining like terms on the outside, I get negative 7. So as we look at our turning point, x minus 3, x minus 7, that was option 1. And I can do the same thing with the next one. Yeah, so that should be good. Let's just practice the same skill. There's, like I said, there's other ways around it. Let me stick with the same notation though of f of x instead of changing it to y. But again, you're going to see me put a space in here and then minus 8 with a space. And my process is looking at that number divided by 2 squared. Well, that is negative 1 squared would give me positive 1. So then over here, I would have to subtract 1. And the whole point of doing that is I can group the first 3 together, and I can factor that out as x minus 1, x minus 1. I don't know if you've noticed it. I didn't want to tell you right away. It's always going to be this number inside of there. Now on the outside, it always changes depending on what these values are. But negative 8 minus 1 gives me negative 9. So this is the form to tell me that the vertex will be right 1, down 9. Now, the last thing to do is they want you to find the x-intercepts. And they remind you that you can find the x-intercepts by setting the equation equal to 0. And factors of negative 8 that had to be negative 2 would be negative 4 plus 2. So we write it out that way, x minus 4 and x plus 2. And then remember the zero product property would tell us that our x-intercepts will be 4 and negative 2. And one more thing before cutting you loose for the homework is that you should notice, I don't know if you did, but the vertex needs to be halfway between the x-intercepts. So if I asked you to find the halfway point between the x-intercepts, and this is why there's a lot of ways of figuring out the turning point or the vertex, is because the x value needs to be halfway between the x-intercepts. So 4 plus negative 2 is 2, divided by 2 is 1. And then to find the y-coordinate, you can always just plug 1, or the x value back into the original problem. So it'd be 1 minus 2 is negative 1, minus 8 is negative 9. So there's a lot of ways that you can find the vertex. And now you're ready for the homework.